Hey, how's it going, guys? I hope you had a fantastic day. I'm here to share with you something exciting. So, this week I found out about NotebookLM. I got told about this research tool and I want to share this with you. It's the first time I used it, and the very first try I did something on it, I was blown away. So, for the first 3 minutes of this video, I'm going to play you a podcast that was generated using NotebookLM on the Circumfusion book. So, there's spoilers, so just be aware if you don't want to hear anything about the Circumfusion community book, then just skip ahead. And then after that, I'm going to show you how it was made and how you can use this Notebook LM for your research, which is absolutely just crazy.
Welcome back to the deep dive. So you've handed us a source here that I have to say reads like a mix between a conspiracy novel, a history text, and a really sharp critique of modern biotech,
It's a wild ride. We're diving into this world called circumfusion, and our mission today is really to unpack the central conflict.
which is this huge battle between two opposing forces.
Exactly. On one side, you have this really sinister corporate entity called Peel, that's Prime Echelon Echo Laboratories,
And on the other,
a completely decentralized sort of anti-establishment group called the Sketchy Labs community.
and what they're fighting over isn't territory or money, it's basically the future of human evolution.
That's it. And we're tracking this through the story of a brilliant geneticist, Alice, and her friend Ethan.
Ah.
His transformation, which is just shocking. It really exposes the ethical cliff we're all standing on.
But to get the modern fight, we have to go way, way back.
We do. The whole idea here is that our civilization is built on the rubble of a much older, much more advanced one. The source talks about the Edenlands.
A species of small apes.
Yeah, from eons ago. And they had these incredible latent abilities. They could, for all intents and purposes, bend reality with their own genetic code.
So what happened? A war? A plague?
That's the twist. No. They lost their powers because they got bored.
Bored.
Bored, their utopia led to angst and apathy. The source suggests that without any real struggle, they just genetically declined. They'd evolved into us.
Wow. Okay, so that lost ability, that reality-bending code that's buried in our DNA,
That's the prize. That's what Peel is chasing.
that is a heavy philosophical critique right there, that a perfect utopia actually causes us to atrophy. So let's bring it back to the present day with Alice and Ethan.
Okay, so Alice is a genius. I mean, she mastered CRISPR sequencing in capuchin monkeys. That's, the absolute cutting edge.
But Ethan, her friend, he's a musician. He's kind of her ethical sounding board.
He's the one asking that classic Jurassic Park question, the Michael Crichton moment.
Just because we can, should we?
Exactly. And that question is so central because, well, Alice's genius was already being used against her.
How so?
All right, sorry for stopping it there on this cliffhanger, but I don't want to reveal the whole book and the narrative and so on. So you can go and read the book if you want to. Anyway, I just wanted to explain and show what Notebook LM can do. Now, I found out about this research tool this week, and like I said, I gave this tool the book, and this is what it generated. Now, it doesn't only generate these podcasts, there's various things it can generate, which I'll explore this week as well. But I just wanted to show how it worked. So you can go to NotebookLM. This was made by Google Labs, and you get this nice interface. Now, I believe there is a paid version, if I'm not wrong, but for the most part, I could use this for free. Now, here on the left-hand side, you get to add some sources. And as you see, I added one source, which is the Circumfusion book in just a TXT file. But you can add many various type of sources. So I'm going to, in this video, try and add YouTube videos, and we'll see how far we get. Now, it's very straightforward. After you've added your sources, you can add a few more, right? Maybe you want to read something on some kind of math subject, or you have some interest in practicing some specialized field. So you can get sources regarding that, and then you can have these options on the right-hand side to then generate a few things like a report, a mind map, which I'll explore as well, a quiz, flashcards, and then also this audio overview. And this is what you've seen me generate. Now you can see when you've generated the audio overview, you can also have it play in an interactive mode. This mode is quite cool because you can interact with the hosts. You can actually talk to the host who is talking in the podcast, which is pretty cool. You can ask some questions. We'll try it out now. Just want to mention, when it comes to sources, For me, I am playing this on my channel, and that's because, you know, we are the creators, our community. We created this book, so we have access to the source. So whenever you use this and you intend to use it to publish stuff or whatever the case might be, you must just make sure that you have access or can use these sources, that you're allowed to use it. If it's for personal research, then I guess you can use any sources, but just do your research on what type of sources you can consume in this way and which ones you can actually display to an audience, right? However, let's try out this interactive mode. So I'm going to click on this and let's see how this works. Then I'm going to click on play. I hope you
Welcome
can
back to the deep dive. So you've had us a source here that I have to say reads like a mix between a conspiracy novel, a history text, and
so I hope
a
you guys can hear
really
this.
sharp critique of modern biotech.
It's a wild ride. We're diving
Let
into
me
this
say
world called
join.
Circumfusion.
Oh, our listeners got something to share. Let's hear it.
Hey, how's it going? I just quickly want to find out. I know that there's a character called Ethan in the book. Tell me, does the book say where he comes from? Um, what's his backstory? Where does he come from?
Hey there, thanks for joining us.
We love the question.
Okay, let's unpack this for a second.
That's right where
Backstory is absolutely central.
what's fascinating here is that Ethan is a
Grew up in the area.
but his roots, his actual origins are very sinister.
He wasn't just a local kid.
He was actually bred to be a human subject.
Right from birth.
His estranged father.
All right, guys, I have to stop it there. You can see how cool this is. I can actually speak to the podcast hosts and they acknowledge me and then start answering my questions. Now, you noticed how it cuts out the audio. That's not the AI's fault. It actually is saying what it's saying. It's my microphone. So whenever the sound gets a bit low, it starts cutting it out. So I could hear the full thing, but you can try it out and see how this works too. I just wanted to show how cool this is because now if you have some sources here that you want to know things about and is someone who likes studying by listening to podcasts and listening to visual or audio, I think feedback, right? And learning in that way, you can kind of ask questions. I also think this is a phenomenal way of building up confidence when you want to start speaking in public because you can have like people in a room here AI, right, chatting about a subject and then chipping in and then finding way of asking questions and just having fun, talking about a subject. So now let's take a look in the middle here. You've got a normal chat where you can chat to an LLM and then it can give you responses on the sources on the left. Now it's always important to realize the sources on the left is the source of truth. That's where, it gets its information from. And then here you can chat to it. And then in the studio section, you can generate various formats of data around these sources that you've added. That's how simple the interface really is, right? Now, I'm actually going to create a new notebook and then just go through this process with you guys. So let's try this. Let me go back to my notebooks and then click on create new notebook. Just before I add some sources, I just want to kind of let this sink in how phenomenal this is, right? Like let's say you do have, there's a student and they are struggling to learn something on a subject. Maybe they just need to consume the data a bit differently, right? Maybe they can add these sources and then choose a format that's suited for them to consume and study material. I just think it's absolutely brilliant, right? Anyway, I'm going to add some sources here. I was thinking what we could do, I can add sources around the Art Engine 2. The code version, that's a bit of an improvement on the NFT generation tool that I created way back, but it's the second version. Now there is documentation on the Art Engine 2, but I want to see what I can get from passing in these sources. Maybe it can teach me or I can ask questions around things that the community always wanted to know. Can you layer specific items in a specific way? Can you create a one of one? Artwork and these kind of things. And I want to see if I give it enough sources, if it could have that information with it. So that's what we're going to try now. So for the first source, I want to go to the docs. It's kind of relatively fleshed out here. If I go to discover more, here we can see the Art Engine 2. We've got getting started. Now, I'm wondering if it could web crawl this and find how to implement the plugins, right? The Art Engine 2 is driven by plugins, so you can create input generators, renderers, exporters, and it's actually such a phenomenal way of building literally anything you want to into an engine like this. But yeah, I'm going to give it the entire doc back here, and let's say we would like to add a website. We're going to paste that source over there, and you see how it starts gathering the information and then has a little checkbox there, meaning that it found it, and now it's already giving us here some sort of feedback from it. Can you tell me how I can implement the input plugin? I'm just going to ask it, and let's see if it gets some information from it. If it can, then it's brilliant, right? It means it web crawled it and give us something back. So yeah, here it says, okay, cool, core input plugin from the Art Engine is designed specifically to handle image layers. Let's ask it, how does the interface look like? Let's see code. Okay, so here it's saying that the source does not contain the specific details or code, a description of the interface itself, but I know it does, right? I mean, here it even gave the name. So I'm wondering if we should provide these sources or these pages one by one. The reason why I'm saying that is if you go to the input plugin, you can see here that it does mention, if you go down to interfaces, it does mention the input interface. And if we click there, right, it's going to take us to the actual interface. So it should have access to this. Now, I'm going to maybe just define and give each one of these pages to it so we give it the best fighting chance. And after that, I'm even going to add a GitHub repo so that it has extra data for it to look through. All right, so you can see I've added a bunch of these pages, almost all of them, I think. I just wanted to really have a good chance at finding the data that I need. So can you tell me how the custom input interface looks like? Let's send that. Maybe it finds it now. It will be really interesting to see the level of depth you have to go. And look at this. It found it. So I'm happy, right? I gave it the documentation. And it comes down to what I realized, it really comes down to the quality of your resources and your sources, basically, so that you have in-depth, or you can actually ask it in-depth questions. So I found the answer that I was looking for, and it is correct. This is the custom interface that you need to implement. Okay, now I'm going to give it the GitHub repo itself and also the NPM library where it can find that as well. And then I want to try and add some YouTube videos. You can see here my source limit is about 50 sources. Don't think we're going to reach that, so it's fine. But here on YouTube, I do have a series on the Art Engine 2, and it's various things, right? How to implement the plugins, the renderer, the generator. I just want to give it as much data as possible. All right, so I basically have added the playlist as well. You can see here's all the YouTube videos and all the documentation. And then here at the end, it had a bit of a problem with the NPM link. So I'm going to just remove that source. It seems like I've tried to add it twice now. It doesn't want to do that. But anyway, we got all the sources on the left. And now I'm simply going to decide which type of data I want from this. I'm definitely going to try the audio overview and play you the entire clip here so that you can see what the output is. But we can also later on in other videos try some of the other ones as well, which I'll also make a video about. Now, keep in mind when you generate an audio overview like this, which is the podcast type of fashion, it's going to take some time. I notice it takes quite a few minutes, but keep in mind it's generating, the actual podcast itself. So it's not going to be quick. Now, let's leave it here and I'll be back and I'm going to play you what it generated. And let's see if we learn something about the Art Engine 2.0. All right, then it's done. Look, it didn't take that long. It did it in a minute. So that was actually very impressive. And it generated a 12-minute long audio clip. Now, I'm going to leave you and have you listen to this podcast, the entire 12 minutes. If you don't want to, skip ahead. I hope you had a fantastic time with me. But if you want to listen to it and just take it in where we are at with AI and what Google has created here, and see for yourself if you want to use something like this. Anyway, I hope you enjoyed the video. For the rest of the video, I'm going to leave the podcast running. And I do hope that you enjoyed your time with me today. If you did, leave a like, comment. I always appreciate that. And then I'll see you in the next video. Cheers for now.
Welcome to the deep dive. Today, we are taking a sledgehammer to the architecture of one of the most foundational tools in generative art today. I'm talking about the HashLips Art Engine 2.0. If your work involved layered digital assets, and I mean, whether that's standard 2D collections or something, way more ambitious, this engine is where efficiency starts.
That's absolutely right. At its heart, AE 2.0 is an NPM package, a really powerful, versatile core designed for layered creation. But the key thing to get is that this isn't just like an update, it's a total overhaul. They literally threw out the old, super popular OG HashLips Art Engine and built this new version completely from the ground up.
And we really have to spend a moment on why they did that. I mean, the OG engine became the standard during the NFT boom. It was fantastic for layered JPEGs, basic metadata. But that success created a huge problem, right?
Feature creep.
Oh, massive feature creep. Users started wanting things like incorporating 3D renders or video clips or complex logic that needed to call an external API.
Things it was never designed for. Exactly. The original code became this labyrinth. It wasn't built for extensibility. So every time a new feature was bolted on, the core con just got harder and harder to read to maintain. Imagine trying to add a new wing to a house that's, already on a shaky foundation. The developers realized they couldn't just keep patching it. They needed a new scaffolding, something modular, robust, open source, and plugin based.
So that's our mission for today. We're going to tear down that scaffolding piece by piece. We'll dissect the plugin architecture, understand its execution flow, and then really zero in on the one feature that changes the game, the new caching system. Let's jump right into the structure.
Okay. So at its core, Art Engine 2.0 is basically a very disciplined looping mechanism. It's not one giant script anymore. Instead, it orchestrates 4 specific types of plugins, and the sequence, what they call the IGRE flow, is mandatory. Every single time.
IGRE.
Right.
That sequence sounds critical for how the data moves through the system. Let's start with the I, inputs.
Inputs are, they're pretty simple. Think of them as data adapters. Their entire job is to bridge external data sources, your image layers, your word lists, whatever, and just load that raw data into the engine's memory.
So they don't add any logic or uniqueness?
Not at all. They just feed the system. The classic example is the image layers input plugin. It just reads your trait folders and says, here's all the stuff you can work with.
Okay, got the raw ingredients. Now for the G, generators. This has to be where the magic happens, the randomness.
Precisely. Generators consume that raw input data and they start applying rules. This is the brains of the uniqueness operation. This is where your DNA strings get calculated, where rarities are enforced, or weights are applied to decide which traits an asset gets. The image layers attributes generator, for example, is what decides item number 500 gets a gold hat and blue eyes. It creates the blueprint.
So far, so good. Raw data, then a blueprint. The third step are renderers. This is where I suspect things get tricky, especially if you're not just making JPEGs.
You're getting on a crucial point. This is what shows the real power of the new engine. Renderers take the blueprint from the generator and the ingredients from the input and, well, they physically produce the content. This is the heavy lifting. And what's so fascinating here is its capacity for asynchronous behavior.
Asynchronous behavior. Walk us through that. Why is that so necessary?
Okay, so imagine you're generating an NFT that needs a complex 3D render from a program like Blender. You can't have the whole engine grind to a halt waiting for Blender to finish rendering one item. A renderer plugin can kick off that external task, and then it just waits. It waits for the output, and only then does it mark its own process as complete. It could be an API call, it could be an FFmpeg video process.
Wow. Okay, that immediately solves the problem that crippled the OG engine. If you can pause the internal loop to wait for something else, you can incorporate literally any media type.
Yes. And because these external jobs can fail or take a long time, the renderers don't save their output to the final folder. Not yet. They save it to a temporary temp folder inside the engine's cache path. It's like a buffer, a safe holding area.
That's smart. It stops half-finished files from polluting your final collection.
Okay.
And that brings us to the final letter, E, for exporters.
Exporters are the final mile. They just read the completed work from that temporary path and do final housekeeping. So file naming, maybe some format conversion, and then finally placing the files into your designated output path. This is also where things like the ERC721 metadata exporter or the SOL metadata exporter come in to package everything up for the blockchain.
So the whole flow is seed initialization, then loop through inputs, then generators, then renderers, and finally exporters.
Yeah.
And each stage passes data to the next through these these managers, right? Like
Hmm.
generators use the inputs manager and exporters use a renders getter. It's a data relay.
That's the perfect way to describe it. It's a data relay. And that's what makes it a general processing pipeline, not just a JPEG tool.
Right, and this is where it gets really interesting for anyone building custom stuff. To prove that point, let's walk through a totally non-visual project, like creating fake crypto seed phrases from a word list.
This is a great example. It shows the whole IGRE flow perfectly without even thinking about images.
Okay, so start us off, the input.
So for that, we'd use the custom input plugin. Let's call it words list input. Its only job is to read a file, say a words.json file, with 20,000 words in it. And it just structures that into a nice array of objects in memory, maybe the word and its length. That's it.
Okay, so that word pool is now in memory. It moves to the generator. This custom word phrase generator has to apply the rules.
It does. It connects to the inputs manager to get that word list. Then it runs its logic. First, maybe it filters the list. Let's say we only want words 5 letters or longer. Then second, it randomly picks, say, 12 words to form the phrase. And, critically, it assigns a kind identifier like seed phrase generator v1, so the next plugin knows what kind of data it's getting.
That kind identifier seems really important for flexibility.
Yeah.
Okay, so this phrase array hits the renderer. What happens now?
The custom phrase renderer gets that array. And because the renderer's job is to save to that temporary area, it just formats the phrase into a clean JSON file. Using json.stringify with some nice formatting, it saves that file inside the cache's temp folder. Then it passes the file path of that new JSON file to the exporter.
The file path is the golden ticket. Okay, so the exporter grabs that path.
And it completes the job. The custom seed phrase exporter uses the renders getter to get that temporary file path. It reads the file. Now, here's a really cool detail. Instead of just naming it phrase1.json, it calculates an MD5 hash of the file's content itself. And it uses that hash for the file name.
An MD5 hash of the content. Why do that instead of just using the token ID?
It's for data integrity, really. It serves two purposes. One, it guarantees a unique file name. If you somehow generated the exact same phrase twice, you wouldn't create a duplicate file. And two, maybe more importantly, it confirms the content hasn't been corrupted or changed between rendering and exporting. It's a final integrity check before it writes the file to the real output folder.
That is a beautiful illustration of the whole pipeline. So we've established it can handle complex data flows, not just images, which is huge. But all that flexibility is kind of useless if the system is slow.
Yeah.
And that brings us to the performance breakthrough.
Yes, the speed factor. This is what makes the 2.0 architecture truly viable for big projects. We have to talk about the Alpha 5 update and its experimental caching system.
So why is caching the single most essential feature for a generative art developer?
Because generative art development is just. It's defined by iteration. It's endless tweaking. You might change the rarity of one trait from 1% to 1.1%, or adjust the minimum word length in our seed phrase example. Without caching, the engine has to rerun the entire process. Inputs, generators, renderers for every single item, every single time. It's prohibitive. It just kills your creative flow.
Right, you're just sitting there waiting. So the caching mechanism takes snapshots at each stage. How does it know if a snapshot is still valid?
It uses cryptographic hashing. When you set use cache to true in your config, the engine starts generating these unique hashes. And they aren't just hashes of the input files. They're based on the current configuration settings and the final output hash from the stage right before it.
So if I change an input file, that input hash changes, which forces everything downstream to rerun.
Exactly right. Let's trace it. The input plugin runs. It generates an input hash. Then the generator takes that input hash and its own configuration to create a generator hash. The next time you run the engine, it checks that generator hash. If it matches the one from the last run, it just skips the entire generation process for that asset. The log just says, loaded from the cache.
That's so important. That means if I only tweak the word length in the generator, it doesn't bother rereading the huge word list from the input stage. It just starts in the generator.
And this is where the speed gains become almost absurd, because the renderer's hash also depends on the generator's hash. So if the generator was cached, the renderer doesn't run either. It just grabs the file it made last time directly from the cache.
So if inputs, generators, and renderers are all cached, the entire creation process for that one item is basically skipped.
Almost entirely. Like we said, exporters usually rerun because they're about final file placement. But since their input data, that temporary file path is delivered instantly from the cache, the total time is tiny.
Okay, can you give us those performance numbers again? Because this is the real aha moment. This is what justifies the entire rebuild.
Absolutely. So in testing, Running a simple batch of 50 elements with no caching took around 9 seconds. Running the exact same batch with caching enabled took just 39 milliseconds.
9 seconds. Down to 39 milliseconds.
Mm.
That's not an improvement. That's a fundamental shift in how you work. It means you can test 100 changes in the time it used to take you to test one.
It's the definition of a development accelerator. And that meticulous hashing system is what keeps the data clean. Change one pixel in one layer, or one number in the generator config, the hash changes, and the subsequent stages are forced to re-render. So your output is always correct.
Okay, so here's a practical question. If I'm deep in development making tons of little changes, what's the best practice? Should I just leave the cache on all the time?
That's a great question. Here's a pro tip. When you're moving fast and changing things all the time, the safest thing to do is actually delete your cache folder and set use cache to false. That forces a clean, full rerun every time so you have total confidence. Once your logic is locked in, then you turn the cache back on for those lightning fast runs when you want to generate the full collection.
That makes perfect sense. Build slowly and verify, then scale instantly. And the team isn't even done with this, are they?
Not at all. The next big thing they're planning is granular caching. Right now, it tends to hash at the plugin level. Granular caching will eventually detect changes down to individual files or layers, making it even smarter.
So to wrap this up, what this all means for you, the creator listening to this, is that the Art Engine 2.0 is not a simple script anymore. It's a highly structured open source data pipeline. It handles complex asynchronous media, and it was born out of necessity.
And it does all of that with sub-second processing, thanks to that Alpha 5 caching logic. It's a huge testament to the open source community. It's on NPM and GitHub right now, ready to go.
We've seen it handle images. We've seen it handle custom text. It's all built on this incredibly robust and flexible foundation. So this new architecture, combined with that ability to process changes in literally the blink of an eye, 39 milliseconds, it forces a question for you. What truly massive layered media project, maybe a huge collection of generative music or synchronized frame-by-frame generated video NFTs, what project that was previously too slow or too complex to even try is now completely within your reach using this plugin architecture? That's the frontier this engine has just opened up.